All right, we're back. We're on page 4 of notes 13 of Calc C. We're talking about Euler's method, and we're just doing practice problems. Honestly, they're kind of annoying because of the decimals that are involved, but like, whatever, it's totally fine. So let's see if we can do this. So we are given, this is our derivative, and the derivative itself is a function of x and y, so that's going to be an issue. We know that when x is 3, y is -2, so that's our like initial value. So 3 and -2. And then what we're going to do is we're going to take these values in conjunction with this, and we're going to approximate the change in y from this point to the next point. So that's essentially what Euler's method does. I've been changing these to dy's as I go through. And so it's always going to be, I use this notation. I don't think it really hurts you. It's technically not really a correct notation, but I think it's all right. I see people forget delta x all the time. That's like the thing that people forget. So we're going to just start at 3 and we add delta x to get here, and then we add it to get here. So it'll be 3.1, 3.2. And to get a new y value, I'm going to take this y value, I'm going to add whatever the change is, and it gives me the new value. So let's calculate the change for this thing. Do I want to do any of this by hand? I don't really know. It's going to be 1/10. I guess I'm doing this. Should I use I don't know if I should use, let's use decimals to start with, and then we'll abandon ship on that. 0.1. So I need to do x minus y. So 3 minus -2 is 5 over 2 times y, which is -4. So that would be -1.25. So let's say -0.125. So if I add those together, I should get -2.125. And now we're going to do it again. So it's 0.1. It's x minus y. Ugh, terrible. So 5 point, oh, it's actually not that bad. It's 3.1 plus 2.125. So 5.225. 225. Oh, and then I have to divide that by 2 times whatever y is. So let's move that up, and we'll divide it by -4.25. That I'm definitely using a calculator on. Okay, so I'm going to switch to the calculator, but like I basically have my approximation. It's the answer that I'm going to use is going to be this plus this. And then I'll say f of 3.2 is approximately that. So f of 3.2 is going to be approximately whatever we get. So let's go to the calculator. I'll check it and also, get the value. Let's see. So -2.125, and then plus 0.1 times 5.225. So this I'm just doing is like a matter of personal pride to see if I like got it, which like, I don't know. I guess my pride isn't really tied up in that, but -2.248 is what I'm thinking. -2.248, and I'm going to check it on the graph the way that we've been doing things. So I'm going to click, nope, sorry, I was going to share the wrong thing. Doc for graph page. We got to change it to differential equation mode. So menu 3, differential equation. Use fraction template, x minus y1, because we're in y1. So that's like kind of an important thing. It just won't do anything if you do it wrong. Well, maybe. I think that it won't. I don't know why I'm putting that multiplication sign there. I need to put in 3, -2. And then I got to get to those dots. So I just hit Shift Tab on the computer. It might actually be easiest to use a trackpad. Click. And we want, 0.1 is the default. So could have just gone with it. Press Enter. And so you can see Euler's method has a huge issue with discontinuities of any sort. So any discontinuity of the derivative, any discontinuity from the function, you're going to have a problem with Euler's method. Vertical asymptotes are murder. So what's happening here is when you hit y equals 0, because you're dividing by 0, it doesn't know what to do. So it just like goes crazy. So this weirdness over here is probably thoroughly inaccurate, because you shouldn't really cross y equals 0. So at 3, -2, you should start here and really only go this way. And you could go back a bit, but like you shouldn't go back too far, because you go back too far, you're in trouble. So that's where this weird kind of graph has come from. I'm going to trace. So menu 5, enter, start at 3, 3.1, got it. And then -2.2, yeah, woo, got it. Okay. So I'm actually going to stop here because this is the end of this page. I don't know. It's a different day. I know that the last time I made a video, it I think didn't go well, but I don't know. Maybe it did. But I'm feeling better today than I was feeling yesterday when I made those videos. So who knows? Anyway, this is Euler's method to approximate. We don't know how to solve this differential equation, do we? No, we do not. Like, it's not separable, and I don't think we can rewrite it so that it looks like our integrating factor problems. So we don't know how to solve this, but we numerically approximated it, and that's as good as we can do. So sometimes you got to settle for that. All right, so I'll be back in the next video to do some more, and I will see you there.